Hello, Krishna, am I audible?
Yes, sir.
All right. Okay, Krishna, any doubts from the previous topics in this till now?
No, sir.
Um, we had discussed already about the internal instance allowed, which thing which I did. Okay, so I'm just giving you a figure. Okay, we have to calculate equivalent resistance of one unbalanced wheatstone bridge. Okay, okay, equivalent resistance of unbalanced wheatstone bridge. So for this data, we have a very simple figure I have taken for example. Okay, so data, this is the figure. Okay. This is A terminal, this is B terminal. Okay. You can make it as 5 ohms, 3 ohms, 4 ohms, 6 ohms, and this is your 2 ohms. Okay. This is the given condition. So in this, basically, we have to solve this circuit. Okay. Can you solve this case? I even told you a method like how to solve this in the like last class.
Yes, sir.
Okay. For an instant, I'm saying assume the this is connected with 100 volt of battery. It's better you can calculate current flowing through 4 ohm resistor. 4 ohms resistor. Okay, can you just solve this thing? Like if you can solve it, this time, sir. Okay. I'm giving you maybe 15, okay, 5 minutes at max after the selection position. Okay. Kirtan, have you got the answer for this one?
Solving.
Or okay, like, can you solve this or should I solve? Should I give the solution for this one? Kirtan, do I have to give the solution for this one? Kirtan.
$36.3.
Is it the current you have got?
Yes, sir.
Okay, that's fine. All right, people. 6.4, right? Okay. Which method you went with this?
KCS.
You applied KCL, right? So I'm assuming that you may have assumed this to be 0, and this you might have assumed to be 10, right? Is it? Okay. Then you must have assumed this to be some different nodes, maybe x, maybe y. So at this point, if you look at this at x, if we just try to solve it at x, what we are going to get is x minus 10 by 5, x minus 0 by 2, x minus y by 4 by 4, right? And in case this is not about the weak from it, so I'm not as going to assume anything, okay? Let it be, whatever it is. So if you see, if you just try to solve this now, you are going to get an equation. So you can be common out of 5 to the 15 for the 60. So something like that. I mean, 60 is where 5, so let's say 12 minus 120. So 12x minus 120. Here it will be 20x minus 0 as it is. Plus, it should be, or is it 15x minus, this is minus 15y. And if you again just leave, this is 1x, this is the result, and this is third x. Right? You can see those many x we have right now. So it come up as 47x minus 15y is equal to 1. This is one equation we have. The same follow, we can go and build up the other equation. And we will say at this junction, right? So when you're at that junction, we'll say y minus maybe 10 by 6 plus y minus 0 by 2 plus number y minus x by 5 over 6. So yeah, here also if you see the, for what should be the, yeah, in this case my LCM will come out as 12. Okay. Lowest common multiple of all the numbers is 12. So that is 12 itself. So it will be 2y minus 20 plus 6y plus 3y minus 3x. So you can see this is what we have. Finally, you can see that 2y, 6y, 3y, right? 2 to 8 and 11y. So what is it? 11y minus 3x is equal to 2. You can see we have two different, very different equations. Substitute both of them. From here, you are going to get some value of x, okay, some value of y. So if I ask for the current across that 4 ohm, so you can simply say that voltage across x and y divided by the resistance across x, right? And this is what the answer should come. Any doubt written in this point in the solution? Like I have not solved it further part, but you can just do it. Okay.
No doubt,
These
sir.
two equations are, yeah, like these two equations are there having two variables. So to solve n variables, you need n equations. Okay, n variable you need n different equations with those particular. All right, Ketan, I'm going with the next problem. It's a kind of star pattern, or you can say we will discuss a pattern itself related to these kind of problems, but for now, just we will try to solve it in the pattern. A and B. Okay, this is what it is given to you. So can you try to figure out the value? Okay? You can say each register is R equaling across A and B. Now this is your problem to solve. Please solve this and let me the answer first.
Two also.
No, it won't be 2 hours. Please do it again. It won't be 2 hours. Try once again. It won't be 2 hours. Please try to look something which you can neglect or remove it. Something like that. Sorry, I didn't get the value for this. It is also like each of them are is also okay. Equal values.
Sir, is it 2 by 3?
How much case है ना?
2 by 3.
Two, no case. That will be R by two. Okay. Let's see. Yes. If you see Ketana, these two terminals. Okay, just focus on this part for now. You'll get the things by yourself. If you see Ketana, can I say that you, if I just make it over here, it is connected with this point. In between these 2 points, you have R, you have R. Here also you have R. Here also you have. Ketana, if you see carefully, what you can see, the multiplication of diagonal ones is same, right? Or in other way, you can say that this by this is equals to this by this. Isn't it a condition of balance based on which?
Yes.
So if I remove, because I had to calculate R equivalent, I know that it want this thing is not going to participate because there will not won't be any current, right? If I go by using Kirchhoff's law and all, what I am going to do is I will be calculating R equivalent by doing total value EMF divided by the total current, right? So this total current will only have the participation of the resistors who are having current in them, right? But as uh, these two terminals are going to have a equal resistance, we know the reason, right? Balance switch from this. So there won't be any current. If there's no current in this R equivalent, there will be no contribution of this person, right? So if I remove it for a while, just for the calculation of this part, I can simply say that, uh, yeah, I can simply say that this is going to give you the R equivalent, right? So yeah, now you can say that your figure and everything has been, what I can say, is computed into the very small part, right? Or you can simply say now, this is one resistor, this is another resistor, this one, another resistor, another resistor, and the last is this. You have to calculate the, what is it? You can simply say this is 2, this is 2. The parallel, if you do 2 into 2 divided by 2 plus 2, then it comes out as a 2 itself, maybe. I think, is it 2? Yeah, no, it is 1. So basically R, because the resistance value was R, right? Sorry. Yeah, it was 2R in R, so it became R itself. So finally, you can say this is R, the whole thing come out as R itself. You can say that R into R divided by R plus R. What it results out in R by 2. So can I say that R equivalent is equal to R into R divided by R plus R? Please let me know first statement about this.
Yes, sir.
I'm just writing one more problem. Try this one. In this circuit statement, you have to calculate current through battery, current through battery, and current in 8 ohm resistance. Okay? These two things you have to compute. So, sure, we can go with it. The value for these two is 10. 10. So this is the thing. If I just close the switch, what will be the current to through this battery? Okay. That might even say the total current I. So that's what you have to calculate current I and current flowing across this 48 ohm resistor. Any one of you can give like either this or this. Please try to get it in the solution.
18, sir.
Kirtana, how much you have got?
18, sir.
18. Look, two things I asked, like current through 20, battery and current in the 8 ohm resistor. So which one you have got 18?
8 ohm resistor 18, sir.
Wait. Which resistor you have got 18?
8 ohms, the first.
Okay. What you have, I don't know, like, current value you have got 18 ampere. Is it you have got 18?
Yes, sir.
It's incorrect actually. Why, but look Kirtana, if you see carefully, 2 and 8, 2 and 8, if you divide the result is same, I can say that this part is supposed to be neglectable. If you remove this, what you are left with 8, 8, 2 and 2. Again, this part is again going to be neglected. Finally, you can say at the end of the day, after writing everything, what you are left with, after removing everything, what you are left with, only these two. So you can say the net here is 4, 16, and 2. It is again. So what is the net resistance over here? Are you filling comes out as? Like this is 2 and 2. That will result to I think no, 4 and 4 is 2. So 2 into 16 divided by maybe the addition comes out 18. So it results you somewhere around the 18 by 9. This is the R equivalent. So if I ask you current equivalent, you will say the total current to the battery should per potential divided by this. If you look at this 27. Okay. Okay. So what happens is from here you are getting current I is 27. Now this I is getting divided into I1, I2, and this is I2. So if you could remember a way which by which you can simply do this, you know that potential across each of them is the same, right? Because this one, this one, this one, this one, potential is same. So can I simply go and say that I A, what is it? 40 divided by 16 is 3. Can I say this? Can I use this way to solve it? They can take a pause if you think like things are going beyond understanding of discussion. So you can just take a pause for a minute, look at the solution, okay. Come up with your take, like where you are having doubt with. Then we will move to the next problem. That's why this time I'm not going with a lot of problems, like not a lot of problems. So if you feel you are good with this, like okay, it's fine, then I'll give you another problem. Should I move next, or you want to take a pause?
So can't we use I2 is equals to I into R1 into R3 divided by R equal?
What case, you know? Can't
I2 is equals to total current into R1 into R3 divided by R1 plus R4 plus R3.
okay. You are saying that okay for this one case now I2. Okay, you are saying that won't be I2 is equals to total current multiplied by um, R2. What I'm left with the equivalent of this one and this one, right? So let's say this is R1 equivalent, R2 equivalent, R3 equivalent. Because we are here, so you will say, is it what you are trying to say, Kirtana?
Yes, sir.
Okay, let's look at it. Will it be correct or not? Kirtana, in the denominator, do you really think it should be this one? what I told kids, na, if you have three numbers, okay, if you have three numbers, the denominator should have a pairs of three minus one numbers, right? If it is like three numbers, so you have to take pairs. Like it should be R1, R2, R2, R3 plus R3, R1. Okay, you can go with this. Look now, like why you don't have to get like you don't even have to get confused with this part of it. You can simply say that I know what is the potential across these terminals, right? 48, 40. And what is the current? Current is basically whatever the potential you have, whatever the resistance you have. If I know that, I can simply say that current is nothing but total potential across these two terminals divided by the resistor over here, right? I got your intuition, like you are saying, we have studied one formula that if I know the total current I, if it is getting divided into three, so I don't want to use direct formula. Okay, I know this I. Can I get I1, I2, I3 on the basis of this resistance divisibility? Yes, yes, Kirtana, we can do this by this formula. Okay, but here it should not be this. It should be this. Okay, is that clear, Kirtana?
Okay, sir.
All right.
Yes.
Okay. Assume instead of this three, you have another one more four circuit. So what you are going to do is assume I'm calculating I1. So I'll be writing total current. What you have to do instead of I1, write the rest of the part 2, 3, 4, right? All three. What is the total is 4 registered, right? So now you have to make a pair of three. How you are going to make a pair of three? It will be actually bigger pairs, okay, not a very simple pairs. Let's, uh, current is supposed to be this. Yeah, you have to take the pair of the three. So what will be the pair? It will be like R1, R2, R3. Then you will see R1, R2 will stay here. Change R2. R2 is already there. So R1 and R2 is already there. So what you can now change is keep R. Now we are done with these things. Now what you can do? Same thing. Okay. Now you can just change R2 from this the same question. Let's say you are saying R1, R3. Let's keep R3, okay? Because I know R2 is already done in this part. So R2 is not done, so I'll keep this thing. Okay, what I can keep further? I can say that R1, R3, and then I'm left with no. R2 is already done. So finally, you can say that R2, R3. Okay, this is the pair you will be getting. Okay? And again, here now notice, if you have three resistors, the total multiplication, like total addition will be three. If you have two, in case of two resistors, what we used to have R1, R2 was there. So we remove one and we just keep R1 plus R2. In case of two resistors, we just have this two. Here, in case of four resistors, we have total four addition terms. Can you see this part?
Yes.
Okay, so your equation was quite correct. Just a small slight mistake in the formula. Okay, so I'm not remembering the problem. Okay, Ketna, this is the last problem for today's session. It's a symmetrical lecture, basically. It's about the symmetry. Apart from this, Ketna, like for this chapter, try to solve more and more problems, okay, on the basis of these circuits. If these chapters are mostly like more of like whatever number of problems you practice, it will help you much more. This is B, this is B. All the resistance are have the same value. All of them have the same value. This is the thing. So you can try this through the last problem for today's session. By this we end the session. Okay, now let's do one thing. I am giving you two figures. These two are as a homework for you. Okay? Don't do it right now. I am giving you these two as a homework. This one is this one. homework. Okay, homework 2. So that Kirtana, you have to calculate RAB. Okay. A suggestion which I can give you is you can try to solve this problem after this one. Okay, it will help you a little bit more. Although it's kind of tricky problem, you have to think a lot, but okay, no problem. You should do it. Okay. I'll just mark all the points A, B, C, D. You can call it as E. From here, we start. Call it as E, F, G, H. Okay, mark it out. So yeah, you can just call it. Sorry, B is already there, so this is the correct. So you can say that you have to calculate potential across A and G. Okay, that's the thing, Kirtana. That's all for today's class. Any doubt which you want to ask?
No doubts.
No, right? Okay, Kirtana. So by this, I'm ending the session. Okay, if you think any doubt or something there, you can click on the condition. We'll take your class accordingly. Okay? Goodbye.